Hi everybody. So in this video, we're looking at limiter circuits or clipper circuits. Okay, so what we have going on in this circuit is we have AC source, current limiting resistor, we have a diode and a DC source, and we have a load resistor. Okay, so we have the AC source and the DC source, and what the function of the circuit is going to do is clip off a certain portion of the system, of the signal, that's above or below a certain level. It could be used in protection circuits, and let's look at various arrangements of how this can function. So let's look at the example that we have on the screen. In terms of polarity, in the positive cycle, we're going to have that polarity, and for the diode to be forward biased, we need that polarity. So we can see that the diode will be forward biased if the input voltage in the positive cycle gets above the V bias. And looking at V bias with the plus sign here and the minus sign there, V bias is a some positive voltage V bias here. Okay, so it's some positive voltage, and when the input voltage gets above this voltage, so for this little region here, the diode will be forward biased. Now, when the diode is forward biased, and this is what's going on in this bottom diagram here, in analyzing these circuits, they're assuming the drop on the diode when it's forward biased is actually 0 instead of the 0.7. Now, you could assume it's 0.7 if you wanted to, but the initial analysis is a little bit easier if you just assume it's 0. Okay, so with the diode forward biased and conducting, allowing current to flow like this, so that there's a path between here and here, the output voltage will now be limited to this V bias because the load resistor is actually in parallel with V bias. And so that is why on the output here you see for that region it is it's capped at V bias. Now when the input voltage falls below V bias, the diode is no longer forward biased. And if the diode is no longer forward biased, as shown in this diagram down here, it's like it's open circuit, right? So in that case, the voltage across the load resistor is determined by a voltage divider between these two resistors, which is what we have here. So it's going to have the same shape as the input, but it will be reduced in value, and that's that second portion there. Okay, now the tricky thing comes in when you consider that this diode and this power supply, this DC power supply, could be flipped in direction, either one or both of them, and so that gives us a lot of scenarios to consider.